Hello Precalculus student. This video is for chapter 4.4, graph of log functions. We like to graph log functions. So to begin with, we'll graph the parent function, and then we'll graph other function based on it. Now, since log function are inverse of exponential function, like we have talked about in 4.3 before, so whenever we have a log function, there should be an inverse, and the inverse is an exponential function in such a way that the input of the log function is the output of the exponential function, the output is the input, so x and y switch. And following this, then that means the domain of the log function is the range of the exponential function. And the domain of the log function, so that's why domain of the log function will be just the general log b of x is x is greater than 0. Why? Because the range of an exponential function, look at if I have y equal to b to the x, b has to be greater than 0. So anytime you put an exponent to something that's greater than 0, it's always 0. So the range is from 0 to infinity, right? You can tell by looking at the graph of an exponential function that it is either this way, or that way. So they're all above, the y is all above the x-axis. So range is from 0 to infinity. So in such a case, then the domain of the log function will be from 0 to infinity is x is greater than 0. Anything that you input here, which is was the output of the exponential function, must be positive. So this is a key information that you need to know. Domain of any log function would be, no matter what base you have, greater than 1 or less than 1, you would be the expression of x and inside has to be greater than 0. So to find domain of the log function, you solve the inside of the log expression has to be greater than 0. So, so this is the steps to solve a domain of a log function is to solve the expression of x inside logs greater than 0, right interval notation. And then you can also write the vertical asymptote, which is the leftmost or the rightmost value in this interval. Okay. Okay, so do an example. Find the domain of this log function. So this is not just a parent function, but it's log 4, and then 2x plus 1. So we say the domain must be inside this area as the output of the exponential function. This would be the input of the log function. The input has to be positive. So solve it greater than 0. So 2x is greater than negative 1. X is greater than negative 1/2. In interval notation, it is negative 1/2 all the way to infinity, right? To infinity here. So interval notation will be negative 1/2 all the way to infinity, not including negative 1/2. And negative 1/2 is kind of like the leftmost boundary. So the vertical asymptote would be x is equal to negative 1/2. It would not touch negative 1/2. It's approaching negative 1/2 from the right side. Second example, I have log. This is another function, 5 minus x. So again, okay, I should write domain. Okay, find domain and vertical asymptote. So only look at this. If there's any plus or minus or multiply outside, you don't need to care. Only the inside, 5 minus x, you can say domain is 5 minus x is greater than 0, or 5 is greater than x. Write it back. It will be x is less than 5. X less than 5 means you have 5 here. Oh, it should be an open circle. All the way to negative infinity. So in interval notation, you'll say domain is negative infinity to 5, but not including 5, so that the vertical asymptote is x equal to 5, right? At 5, that is the last point that it will touch. So that's how we find vertical asymptote and domain. Basically, look at the inside of a log function. It has to be positive. Now, how do I graph those functions? Right? If I want to graph it, we'll start by graphing the parent log function, like the basic one, with just log x, log base bx, and then we will do transformation to graph the others. So let's graph a few of the different log B function. In general, we will have one where B is greater than 1 and the other one where B is less than 1. So we usually build a table, and I'm going to build a table horizontally, XY, right? So how we would normally we'll pick X and then we'll pick Y and then we'll calculate Y. But because it's a log function, it's easier to generate a exponential functions. So we'll say inverse of this function is what? Inverse is Y equal to the exponential 2 to the x, and you know how to do 2 to the x because so we actually do 2 to the x first. 2 to the x, when we build the table, will be 0, -1, -2, 1, 2. Some positive, some negative, because the domain of exponential function can be anything. And then I know 2 to the 0 is always 1, 2 to the 1 is 2, 2 to the 2 is 4. 2 to the -1 is 1/2 because it's just a reciprocal of 2 to the 1, and then reciprocal of 1/4. Reciprocal of 4 is 1/4. Then I'll just write log 2x. So if I want to build the table for log 2x, my xy would be what? The switch x and y of the inverse, which is this. So I would just copy the y that they have. So instead of picking -1, -2, actually I pick 1/4, 1/2, 1, 2, 4. You can see the domains are all positive number. And then for y, I just switch this 2. So I'll copy the -2, -1, 0, 1, 2. So it is easy to build because you are doing the inverse. You build the exponent function and then find the inverse to build the log function. Now you're ready to graph the log function. Now when you graph the log function, treat the 1/4 x as really x. And you can tell that the domain is x greater than 0, right? Domain is x greater than 0, so that vertical asymptote is x equal to 0, which is the vertical line here. So this is the one that's that the graph don't touch. And then we'll graph this at 1/4, really close to it, is go to -2. At 1/2, it go to -1. At 1, it doesn't go up, it's 0. At 2, which is here, it go up to 1, and at 4, it go up to 2. So the graph in general go like this. With the asymptote here, this VA x equal to 0. Okay, so that's how you graph a parent function. The parent function consists of the log function, basically doing the exponential function like reverse. Usually we pick x table, the table we pick x, but you pick y, or you can write the 2 to the x out and then switch them. Okay, so let's graph another one that is log 1/4 of x. So b is less than 1. So again, what is the inverse? The inverse is y equal to what base do we have? 1/4, right? 1/4 of x. So we'll build a 1/4 of x table, xy, y equal to 1/4 to the power x. So again, when we build exponent, it's very standard. You have 0, -1, -2, and then you have 1, 2, you would have 1/4 to the 0 is always 1, 1/4 to the power 1 is 1/4. 1/4 power 2 is 1/16, which is less than 0.1. And then this would be the reciprocal of 1/4 to the -1 is actually 4. 1/4 to the -2 is the reciprocal of 1/16, so it's 16. So, and then we can write the log 1/4 x now, which is the flip over of xy, right? So you would write there 1, 2, 3, 4, 5. You would write the x as from y, 4, 1, 1/4, 1/16, and then you write the x as the y. Very easy. So it is harder to build this because you really don't know what to pick. How do I know I pick one? I pick 16 and 4. It's harder. So you start off with the inverse function, build a table, switch at x and y. So now we're going to graph log 1/4 x. So start is 16 negative 2. That means I graph from the right side, right? Or you can graph backward. So I just follow this table. At 16, I go down to negative 2. At 4, I go down to negative 1. And at 1, we stop at 0. At 1/4, we go up to 1, right? And at 1/16, which is really close to 0, it goes to 2. So you can see that the graph look like this. So these are actually the two types of graph for log function, parent function. So this is log 1/4 x. The other one was log base 2x. So the upper one is, of course, is more popular or more general. So and of course we need to graph y equal to ln x. ln x is a very popular natural log function. So what is the inverse? We need to know how to graph it because a lot of formulas are based on e and ln. The inverse would be y equal to e to the x, right? Base e. ln is base e to the x. So let's build a base e to the x first, right? Build the e to the x function because it's exponent. It's easy to pick the x and calculate the y because you just do exponent. 0, negative 1, negative 2, 1, 2. E to the 0 is 1. E to the 1 is e, but I want to write 2.7, a rounded number. E squared is 7.4. Just write a, round number. E to the negative 1 is 1 over 2.7 is around 0.4. And e to the negative 2 is 1 over 7.4 is kind of close to 0.1. So this is the e. Although you need to use calculator to find this, but it's easy to build. But now we are ready to do ln. Y equal to ln x. We will just copy this table, but switch to x and y because they're inverse of each other. So the 5.12345 is 0.1, 0.4, 1, 2.7, 7.4, and then the y will be negative 2, negative 1, 0, 1, 2. So when I graph, I don't care about e to the x, but I use it to build a table. I don't need to graph it. ln x would be at 0.1, it goes down to negative 2. Right? At 0.4, it goes down to negative 1. At 1, it doesn't go up or down, it's 0. At 2.7 is 1. 2.7 is 1. And at 7.4 is 2. So all the way to 7.4 is 2. So it is a very general log function graph. It's something that grow. You can see that it's something that kind of grow very quickly before 1 and then sharp, just slow down once it passes x equal to 1. So let's analyze some of the characteristics of the log function. So if you are to solve for domain, solve for x plus c. For a very general log function a, log base b, x plus c plus d. X plus c is inside. The domain is solved inside greater than 0. The range is always a real number. The vertical asymptote is always x equal to negative c, right? Because it's the leftmost or rightmost number. Y-intercept is what? Y-intercept is set x equal to 0, so you just plug in x equal to 0, so it's a log c plus d. If c is positive. If c is not positive, it would be none. So sometimes you would not have y-intercept. Just imagine if your vertical asymptote is all the way on this side, so the graph would just go this way. It would never touch the y-axis. X-intercept is to solve this equation. Okay, solve 0 equal to log base b x plus c plus d. Or axb, I think I forgot this. A log b x plus c plus d. So just do two examples. So find domain, range, and x and y intercept, because after that, then we can actually graph them. Or actually get some points so we can graph them. And later on, we will analyze this to see how we can graph by transformation. So I'll talk about how to do this in the next video.